I'm interested. I don't see it. Oh, you're doing just plus equals plus 1. Oh, okay. Oh, you increment 1 inside here. Oh, okay. That's fine. Yeah. It's just one loop doing the same kind of thing.
Did you break your egg?
Toe.
Oh.
Fractured toe. I stepped on the corner of my couch.
Ow.
Yeah.
How did you stub it that hard?
That's what I want to know. I'm under the impression that my toe is weak. I clearly needed to do toe workouts more. But
Wait, how did you call the boy thingy at the top?
point at the top. Okay, so let's come back. Okay, so 2 things about this. So you can define the method above and declare it below, or you can just declare it above. For this to not throw an error on this line, it needs to have seen this method, at least declared. Okay? So this is a declaration for mult table. This is an implementation for mult table. Okay? Alright. You guys understand that? Declare it, implement it. It needs to see the name of this method at some point before you use it. That's the requirement. I generally do it like this, where I give it the above. So this looks like a table of contents almost. So basically in the order of my methods, it just pastes it up here. So I can easily be like, oh, what, if this is a bigger file, there might be 100 methods. I can just go, oh, there's mult table. I know it's in this file. I don't have to like scroll through 100 lines of code and be like, where's mult table, and like be panicked. So that's why I do this. Again, it's fine to just to delete this line of code and just implement mult table above your main. That's fine too. But I would recommend this way. It's a little bit neater, easier to read.
Can you go back to the first one?
I'm gonna
And how many lines of code did your program take?
whatever, to be honest, I don't know. It's whatever's right up there. So 4 lines, I guess, if you don't include braces. 2 for loops, 1 printout, 1 end line. But it probably takes like 8 or so with all the braces. Yeah, and like I said, the original problem was just to do a multiplication table to 10. You didn't have to make it scale. Like this is the hard answer, and then mine was like the ultra hard mode. If they're even hard mode of hard modes, I guess.
The Dark Souls.
The Dark Souls edition. Yeah. Please no whiteboard day.
I think you showed us how to assign an array using, I forgot the code, but you said it like last week on Thursday.
Yeah, we're gonna do more. We're gonna do arrays today, as this is a great data structure. Honestly, superb. Okay, we got this now.
Wait, mine isn't working.
Isn't working. That's an interesting. We need it. delete the semicolon after top level vector. Oh, you need like a main or something to run this as well.
Like here.
And you also have, I think, an extra extra brace. Yeah, you need a main to run it. You have to call it in some way. Like in I'll scroll up. Oh my gosh. I'm not breaking my other toe yet. No, I just scrolled all the way up and down. Oh. In main. You can put void there or nothing. It's your choice. They're the same. Oh boy. So arrays are today and pointers are forever. Oh boy. Awesome. We may do a project file instead then. Gross. This class ends on the 6th? 3rd?
I think 31st.
30? Yikes. Okay.
Okay, it still has the same error.
Same error.
Actually, it has
Where the
sorry.
Oh, you need to do some like function in the bottom.
No.
Oh no, you don't put it in your main. You have to call it from the main.
Oh, so in main goes before it.
So you want to, main has its own braces, like the same way it's like a function. Okay. Wait, no, main itself. Yeah, now below main, it has the open and close brace.
So
To write code in. Yeah. You're gonna have to write code in main.
we need something else.
Yeah, you need some code to call it. Like that. To write code in it. And then delete the semicolon at the end of people. Yeah, see, so my main looks like this. You put braces between it. Right below it to call it to write code in it. The same way you have a function and you put braces to write code in it. We may just cover pointers and then call it. Class that ends on the 31st. We'll have a fun little in-class project for 31st. I'll bring snacks or something if I can. We'll see. Depends. Are we good? Then we're going to cover arrays now. Ready to go? All right. And let it be so. Okay, I know it's going to be sad, but I'm going to delete all my code. I'll only miss it a lot. Okay. Okay. So, we're going to do arrays. Arrays are really convenient for looking at creating information that's repeated. So for example, if I wanted to store 100 values, what's the current way we do that? If I want to store 100 values, every integer value from 1 to 100. 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 68, 69, 70, 1. What's the current way we do that? So we probably do that with 100 variables, right? And A equals 1, and B equals 2, and C equals 3, and D equals 4, and E equals 5. That's kind of repetitive. In fact, that's almost 100 lines of code, just storing 100 values. So arrays are a beautiful invention for doing this. We can do it. So an array, we can imagine if we said our set of memory. No, don't die already. I haven't even started yet. So if we have memory, it looks like this. If we decide a block of memory is right here for A, an array is basically a bunch of these in a row. Okay? So here's an array. It's a bunch of them. So here's 1, 2, 3, 4. This is maybe one block. 1, 2, 3, 4. This is another block. This is another block. This is another block. Okay. So it's a bunch of contiguous locations in memory. So what this means is basically there's a certain number here, number there, number here, number there, and they're stored just directly in a row. No gaps in memory between them. Okay? So here's how we do it. So I'm not going to type out exactly how to initialize the numbers from 1 to 100 with 100 variables, as I kind of like teaching this class and not typing numbers. So here's what we do. We use the same identifier for an int, then we give it a name, like in numbers, and then we specify that this is an array. Okay? And it'll make us give us a number probably. Yeah. So let's say 100. So this is also an introduction to a new operator as well. This operator is called the index of operator. And understanding how it works requires a couple of little detours. So, index of is an operator that uses braces. It takes in an integer right here. And usually it takes something next to it. For example, the array name. And what it does is it goes and finds that value. So for example, values are numbers starting from 0, 1, 2, 3. If I would like the second value, I say I would like the second value if the array was called numbers. I specify I want this value. Even though it's really the third number, this is indexed to the third value. Okay? Just a warning, they start from 0. So this would give me exactly that. If I wanted the zeroth index, I can do number 0. Okay? So that's how we talk about an individual location in this. So, here's our example. Like I said, it would take 100 lines of code or one incredibly long line of code to get 100 values. What we can do is this. For int I equals 0, or equals 1. I is less than or equal to 100. I plus plus. Numbers I equals I. So what this did was I created an array with space for 100 integers. Their indices are 0 to 99. I then started and created all the numbers up to 100. Sorry, I should probably actually make this 0 just to be a little bit better. Just be a little bit more correct. This would be the more correct implementation. Sorry. So, does this make sense so far? Just like the intro basic to it, an array. It's like one block of integers in a row in memory. So, an interesting thing is, how does it know? How does it know to go find one of these? So, what it does is, when it looks for a number, the amount of slashes I've done here before really didn't mean anything until now. They're going to mean something now. Every integer is actually 4 blocks. Okay? This is actually a byte of memory in your computer. But an integer is 4 bytes. So when I say I want the second index, it says an integer is 4 bytes. Multiply that by 4. Bam. So this is 0 integers away from the start. And that's where that comes from. Okay? 0 integers away from the start. 1 integer away from the start. 2 integers away from the start.
Can you move the screen?
Yeah. I'm also going to make it bigger in a moment. I'll use the presentation mode. Okay, but was this clear really quick? How that works? So an integer is 4 bytes, just 4 slashes. If I want the second one, I go 4, 8 away from the start. 4, 1, 2, 3, 4, 5, 6, 7, I didn't draw an 8, but 8. And then I get to number 2. Okay? That's how it does that. So really quick, I'm going to introduce something called size of, and we're going to have a little bit of fun printing it out. So, like I said, an integer is 4 bytes. We're going to find out what some other things are. Like, what's a double? How big is a float? In your computer, what does it store? So, really quick, I'm going to show, you can ignore this for now. I'll comment it out. So, really quickly, we're going to see out, and we're going to call this size of operator. Or sorry, the size of. So, for example, we could do ints. Size of int, size of double. What I want you to do is I want you to do this. Do size of bool, size of int, and size of double. Okay? Bool, int, double, and float. Actually, let's do all of them.
No, where's the binary pad?
Okay. Cool. Did you guys run this? All 4? Okay. Did we try it? Looked at it? So, I did mine in order Boolean, int, float, and double. And I get 1, 4, 4, and 8. So, what this gives us, this returns the size of function, gives us the amount of bytes, whatever you are passing in is in memory. Okay? So, I'm using the standard types defined in C++. You can even call it on your own variables as well. So here's the cool parts. So in our memory block, we're just going to do a little bit of a demonstration as what these actually look like. So here's our Boolean right here. 1 byte in memory. 1 byte is also 8 bits. Okay? If you're interested. It looks like this. Okay, just as an example. So the next one I said was integer value. I said it was 4. So right here. Here's an int. Okay? It stores some binary number across all of these. So like 1, 0, 1, 1, 2, 4, 5, 6, 7, 8. Okay, that's like some integer value stored in bytes. The next one's a float. The float looks exactly like the integer, and so on. They all look like this in memory. So I'm going to do a double down here. 1, 2, 3, 4, 5, 6, 7, 8. Almost. Okay, that's our double. So what the one thing you can kind of understand a little bit about is how big are these numbers in memory? So how big is a byte? Not that big. 1 byte for a Boolean is not very big. Because you talked about your internet tool, you have a 500 gigabyte hard drive. What's a gigabyte? That's 10 to the 6th bytes. Okay? You can store 10 to the 6th Booleans on your hard drive, which is a lot. So that's just kind of give you some idea of like what's a gigabyte, and that's what a byte actually is. It's 8 numbers. So now that we did size of bool, int, float, and double, I want to show off an interesting thing about our integer one. So we created our integer numbers. What happens when we call size of on that? Whoops. What do you think happens when we call size of on that? On our nice big integer array. I'll even delete these for now. How big do you think this will be in memory? How interesting. It's exactly 100 times that of 1. But, so, basically, I wanted the size of an integer. I said it's 4 bytes. I create an array with 100 integers. What's the size of a 100 integer array in memory? 400 bytes. Because 100 4-byte integers is 400 bytes total. So, with that, we will do creating it with, whoops. We're gonna do a little bit of like actually how to look at arrays and like deal with them. Okay, and that'll be the majority of today. So I would highly recommend internalizing exactly how this for loop works. I will talk through it as well, but just try to internalize this one. So down here, I say I create I. I say I is equal to 0. Is I less than 100? It is. Numbers I or number 0 equals I plus 1. So location 0 gets number 1. I increment I from 0 to 1. 1 is less than 100. Numbers I equals I plus 1. Location 1 gets number 2. The integer value 2. I increment I from 1 to 2. 2 is less than 100. Numbers 2 gets value 3, and so on. Okay? So I'm going to print out, I'm going to go up to just 10 on this one. But I'm going to print it out now. This is another good one to memorize or understand exactly how it works. Oops, numbers I. Okay. So I'm printing out the values up to, I didn't. So really quick, I said the size of the int was 4. I created an array with 10 integers. Its size is 40. So here's what I did. I just printed out the numbers just to prove to you I assigned the numbers 1 to 10 in my array, up to 10. So my first question to you is, so there are 10 locations, right? I said there were 0 to 9. What happens if you go for one that's not there? What happens if I put in location 32? What happens? Actually, I'll keep that for now. And then I will make this a little bigger. So, whoops. So what happens if I ask for a number that isn't there? What happens? Or what do you think happens? Do you think it's an error? Do you think it has brought trouble? So, actually, there's no error at all. It says that's fine. It prints out some 0. I'll comment this out for a moment. Right now, it just printed out 0. Okay? That's convenient. What happens if I ask for an even bigger number? What about like 285? I get negative 2,142,196,695. Great, exactly what I wanted, right? So here's what happens when I make this call. So in other programming languages, there's protection against this. Okay, this is what's called an index out of bounds error in other programming languages. I said this array has 10 values. I attempted to request the 285th value from it. That's a problem, right? Agreed. So what happens is understanding how it finds a number. So, like I said from before, if I want the second number, I'll jump 1 integer size in memory, okay? So, I'll start at the start, and then I'll jump 285 times however big an integer is. In this case, it's 4. So I will jump 285 times 4 memory locations straight down, and then go right there and give you whatever's stored down here. Okay? Notice how maybe this is our array right here, for example. Notice how it ended, and then there's a whole bunch of other memory. This is actual memory your computer is giving to other applications. Okay? This is a very low-level programming language. So I may have requested memory from CLion, the actual application. That may be part of the thing is storing it might be in the middle of storing an integer and then also storing part of the color that is the X button, for example. Yes.
So how do you dump the memory and see all the values?
How do you what now?
Dump the memory.
Dump it? It'll do.
So you can see.
So there's a thing called destructors that you get to in classes for deleting objects of your own creation. C++ also does it for you. We're not going to get to that. Most likely, we're going to run out of time before we get to it, unfortunately. But it does it for you. It keeps a record. When you create these values, it keeps a record of the memory location and how big it is. And then that's how it requests it from Windows. It says, when you say I need an integer, your program goes and tells Windows, I need 4 bytes of RAM. And Windows says, here you go, done, easy. So you take it. Then your program ends, and then your program basically says, okay, I'm done. I don't need it anymore. And Windows says, great, we'll take it back. Okay? So, but the weird thing about that is it doesn't take it. All it does is say that it's reserved. It won't give it to other people. So, when I requested the 285th location down my array, I jumped into some other application. It may not even be my code anymore. It could be sea lion. It could be whatever was stored on the hard drive from before. This number, there's no guarantee this number will be useful at all. There's no guarantee it will be 0. There's no guarantee it will be positive. There's no guarantee. It's a gibberish number. So, the way to avoid this is to understand exactly how the memory works, and I don't know memory so much. Take advantage of it. So, in our example from before, I said that a singular integer has some length. Okay? And it's 4 bytes, right? We can agree on that? So if I didn't tell you the size of my array, you know, maybe there's 10 values, maybe there's 13 values, maybe there's 52 values. How do you know how many locations are valid to get to? There's actually a formula for that. It's very popular, and I will show you how to do it. So, we have to start with our premise at the start. So, our first premise is that we know the type of it. So let's go, for example, let's do shorts. Shorts is a data type that stores very small numbers. Okay, it still stores integer values. Or no, do you guys know characters? Have you talked about characters? Singular letters it stores. Okay, we'll talk about characters. So we have a character array. We know that. Okay. It's some size we don't know. So here's how you can calculate how big something is. So we know how big a character is, right? That's size of character. I don't really care what this is, but I know this number basically. I can compute it with size of. And I want to know how big this is. So another thing we can do is size of, and this is called characters. We can divide one by the other and get our answer. So the actual size of it is equal to size of characters divided by size of what a char is. Okay? In a more general sense, the formula to compute this is the size of the array divided by the size of the data type that it's storing. Okay? As an example, I believe a character is 2 bytes. Okay? So let's say it's 80 bytes. Okay? This whole thing is 80 bytes. This is 80 bytes. The size of a character is 2. There are 40 values in my array. Computed. Okay? So the addressable locations are 0 up to 39. All right? I understand that? I will demonstrate as an example. So I'm going to create a 40. So we're going to do character. We'll create a character array. We'll make it size 40 just to show you. So what I'm going to do is I'm not going to fill this with any values. So this will be probably 2. This will probably be 80. So really quick, for loop. One second. Okay. And I is less than, so we're looking for that maximum address. So we can do size of numbers divided by, actually I'm going to compute this outside of my loop. So size equals size of numbers divided by, whoops, I need an integer. Divided by size of character. So we can do this, and then we could print out something from numbers. So really quick, probably give us a bunch of gibberish. Yeah, it's going to give us a bunch of gibberish. So size of character was 1. Oh, my bad. So it's 1. A character is 1 byte. So then size of numbers was 40. So we said 40 divided by 1 is 40. And then we say that we can go up to 40, printing out numbers. Okay? So do this. So, with that information, we're now going to do some problems with loops and arrays.
By ourselves.
Yes. So, what we're going to do, first thing to do, create an array that can store 32 values. 32. Yeah, let's do integers. So I want to store 32 integers in an array. I would like it to be called Steve. Or maybe Bill. You can take your pick. I'm not picky. We got it? Ready to go? Maybe. Are we good? Ready to go? Okay, so here's our array. I said I wanted an integer array. I want it to be called Steve or Bill. I'm calling mine Steve. No, actually, I want to call it Bill. I changed my mind. And I wanted to give it 32 values. Bam! 32 value or integer array called Bill. So my next thing I would like you to do is I would like you to print out every value in the array using a for loop. Okay? I will leave this as a hint to help you fill in things. Wherever there are red lines, you should probably fill something in. We good? Got it? Okay. I will fill in for you how to print out every value in an array. This is a very popular for loop. I equals 0. I is less than whatever number goes right here. I'll use 32. We don't have to use the big size calculation yet. All right, then we can see out. We will specify Bill, which is the name of our array, and then we use our index of operator, and we give it I. And that will print out every value in our array. Who knows what's in this array? We didn't actually get any values. So it's going to give us whatever's in memory. As you can see, those aren't very useful numbers, right? 4, 0, negative 7,642,419,000, 4,200,000,
I got
0, 2 billion it looks like almost.
I got 4 and 0 too.
Yeah, you'll get different numbers.
No, in the beginning I got 4 and 0.
Oh yeah, it all depends. It's very hard to say what will actually happen. So this is whatever's stored in your memory. Sometimes it might be the same. It usually won't. Okay? So I will give you 2 ways to create an array and not fill it with gibberish. So our first example would be to create an array. We're going to switch up this line right here. I'm going to say equals. We're going to use this keyword new. Will not let us do that. Oh, it wants a comma. Never mind, it's sad. Okay. We're going to go like this instead, actually. It doesn't want the new array. So, you're going to use braces. So, here's the rule of thumb for this. There are multiple ways to create an array. You can do it with this number. It just allocates enough space for you. You can also not pass in an exact number, but you can give it actual numbers. I would like you to store 1, 2, 5, 10, and 38. Okay? You tell it very specifically, I want these exact values. I'm going to delete 32 from my loop counter as well. 1, 2, 3, 4, 5. There are 5 values in here. Okay, is everyone clear on that, what I just did? Instead of just not initializing with any value, I gave it some numbers to start with?
Yeah.
Okay. So, to prove to you that I am only somewhat crazy, here's all those values printed out again. Your same code from before will work. If you did not change the I less than 32 to I less than 5, you will get these numbers in gibberish. So, really quick, I will show you the size calculation. So, let's do size. Size of bill. Whoops. So really quick, we'll print it out. Sorry, I'll print out inline. Okay. So our first number I'm going to print out before printing numbers is the amount of numbers we can go up to. Just for my point, there are 5 numbers, 0, 1, 2, 3, and 4, but 5 total numbers. Just to prove to you that I am not crazy as well. And this is how you can compute the size. So even though I did not know the amount of numbers in here, I was able to compute it with a very simple 1 line of code. So from now on, I would like you to use this for the rest of today, that is, at least. Compute the size using the size of the name of your array divided by the size of the data that's in the array. The type of data, I should say. We good? Ready to go? Next part? Thumbs up, thumbs down, nothing? Okay. So, I added a couple more numbers. I had 5, now I have 1, 2, 3, 4, I have 5 more, now I have 10. To prove to you the size calculation will still work. And we still got 10, okay? And then we printed them all out. Even though I had no idea what the size of this array is, I computed it and used it. Okay? So, with that, we are now going to do one quick one. So, what if I would like to print out every other number? This is your first question. I will leave you with this put up here. Right now it prints out every single number. I would like it to print out every other number. So, in my example, I would like it to print out 1, 5, 38, 64, and 23. Index is 0, 2, 4, 6, 8. And then we don't have an index 10, so it stops. Every even numbered value. That will be left for you to consider. Anyone got it? Printing out every other number, starting with the first one. Got it? Oh, the 10 comes from the printing out size. We can do that. That's the outside line above your foreloop. Yeah. Okay, you can keep it, it's fine. Perfect. Printing out every other number. For those of you that have printed out every single even number, how do you print out every single odd number? So we print out 0, 2, 4, 6, 8. How about printing out 1, 3, 5, 7, and 9? What you think about that? We close?
Yeah.
You know, every even number. Index 0, 2, 4, 6, 8. I will give it another minute. Alrighty. So, printing out every other number. It starts at 0. I said I wanted you to print out 0, 2, 4, 6, and 8. We already started 0. Currently, we do every single one. There are 2 ways to do this. The way I'd recommend is just incrementing your I by 2. That would be the preferred way to do it. Because now it goes I equals 0. We print out bill 0 with a space. Then we increment I from 0 to 2 and then print out bill 2. And it doesn't change our comparison against the size. For those of you that were thinking about the challenge, printing out every odd number 1, we can just start at 1. But the other option for this is you can do this as well. So you could have left it as it was before, I++. Another option would be if I modulo 2 is 0, which means it is a multiple of 2. You can print it out. This would work as well. This will give you the same thing. I added 21 to the end, but it'll give you the same thing. Both were okay. If statement or just incrementing your size. We're going to do one more. At least. Hopefully more. All right. For this next one. I would like you... I would like you to store your name in a character array. So I will show you how to do that. We're going to call it name and make it a character array. So you shall do the following. A character is defined with these single quotes. So I will make my name and commas separating between them. I'll just do my O L A S. Perfect. If you don't want to use your name, name yourself Steve or something. Or Bill. I guess we're going to use those 2 names today. Oops. We got that? Ready to go? Okay. What I would like you to do is to capitalize your name. And I will explain how to do so. Okay? So, wherever my mouse disappeared to. Alright. Currently, my for loop that goes through the size of my name will run through every single character. There is an ASCII table. You do not have to know that. You don't have to know any of that, actually. I have a better solution. I believe is upper works. It does. Awesome. Okay. So what we are going to do is we're going to use an if statement. You call is lower. You pass in the letter that you are talking about. I believe there's. Whoops. No, shoot. Killed it. There we go. Here is your hint. If so, is lower is a function that checks and returns true or false if what you pass in is lowercase or not. Okay? Once you can check it. If it is lowercase, I would like you to make it uppercase. So not like that. Yeah, that's fine. Ow. Oh, I didn't print out my name. Okay, once you do this, what you should do is create a loop that prints out your name. And I will leave that for you to do. I would highly recommend a for loop. Or a while loop, depending on what you feel like doing. But I will give you this. Right here. Here is how to... This is how you capitalize your name. Once you have done that, I would like you to print it out below that. After you have capitalized it. Use a for loop. Okay? Got it? Ready to go?
Yeah, I got it.
Got it? I'm going to start typing up the homework. Oops. That's fine. Did everyone have it? Okay. Okay. All right. Here's our name, right? So our important thing is that we calculate the size. No matter what name you put in right here in your character array, it is computed and you can access every single element. So here's how this works. It basically checks, is it lowercase? If it's lowercase, it makes it uppercase. Okay? So for printing it out, I would recommend using that size variable that you computed earlier, and then just going cout. Name, and pass in an index. What you will get is, bam, your whole name in uppercase. Like so. Are we good on that? Yes, no. Okay, I'm going to leave you with part of one to think about and look and do, and then this is going to be a go home and try and fiddle with this code, with the input on this code. Okay, so this next one will be I'm going to keep all this right here. So we're going to do an integer array. So here's what I want you to do. Whoops. So here's your number array. It will be of exactly size 10. You don't have to use our size calculator right now. What I would like you to do is, I'm starting out with 2. I would like the number, so actually I'll make this a little different. 1 second. I'm going to make this 15 actually, so it's a little bit more interesting. So number 0 is going to be 1. Numbers 1 is going to be 2. What I really want is a continuation of every number to the 0 to that power of 2. So for example, index 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 3. I would like you to fill in numbers using a for loop. Fill in numbers. You may want to use a while loop as well. I would probably recommend both. So here's what I will let you think about for a moment. So here's your loop to go through every value. I'm going to start you at number 2, okay? You can do this in one loop, I promise, actually. So, what I want you to do is, in indices 2 through 14, fill in whatever that number was, that power of 2. As an example, number 0 or 2 to the 0 is 1. Numbers 1 is 2 to the 1 or 2. Numbers 2 will be 2 to the 2 or 4. Numbers 3 will be 2 to the 3 or 8. Okay, 2 cubed. Does that make sense? Whatever index it is, I want it to store 2 to that power. Alright? So I will really quickly give you what the numbers are supposed to look like. Zero is 1. 1 is 2. 2 is 4.
Oh, so you just want to...
Is 8. 4 is 16. 5 is 32. Okay? Does that make sense?
Yeah.
Fill in using a for loop numbers. And then if you saved the printing out from below, use that to print it out. I will give it to you as well. Oops.
We just print out the numbers, right?
Yeah, you can just print out the numbers. I will give this one to you though, because we only have a couple more minutes. So I will let you think about that. If you come up with a solution, hold on to it for a moment, as I am creating something. Your homework, that is. Typing is getting repetitive. Okay. Anyone thinking about it? I will give it 1 minute. Sorry, this one's a little bit rushed. But that's just because I need to get to the one homework problem. We ready? 15 seconds. This one is a little bit harder, so also less time. All right. Okay, so I said that I wanted this to be powers of 2. I give you the first 2. You actually only really need the first one, number 0, but I'm giving you both. So I'm starting you out at index 2. What I would like you to do is say that numbers I, which is number index 2, equals 2 times numbers I minus 1. So remember, the last one stored the power of 2. The next one stores the next number multiplied by 2. So really quick, bam, it stores all the numbers. So I gave you 1 and 2, yes? I start from 2, I say numbers 2, which is location 3, is 2 times the previous number. Okay? So in one shot through, I can do it. If you would like to do this with nested loops, you could always compute numbers I using a loop and 2 and the number of 2's. That construction would look like this, if you didn't want to do this weird kind of method. You could also do this. Int value equals, I guess 1. Then for int I equals, int j equals 0. J is less than I, j plus plus. You could also do value times equals 2. And then you could assign it. That was also fine. This, I may be 1 off, but let me just make sure I get it. First try. First try. Also an option. Continually multiply up to I to compute your value. That works too. This was a little bit faster because it takes advantage of previous numbers you've already calculated, but this was okay too. So with that, I'm going to delete this up here, and I will give you code for you to look at and think about. I would like for you to keep this code, note this code down, and I would like you to call it. So you shall use it in this format as follows. I would like you to call it as is palindrome. And you'll pass in a string here. I should probably define it above so I can use it. Perfect. So here's what it will look like. Make sure to define it above so you can use it. Or paste this code above your main. Both are okay. Type in your main, I would like you to print out is palindrome, and then you're going to pass in a string input. Here is the code you shall copy down. I would like for you to test a few inputs and consider what this code does and why. Okay? And with that, once you are done, you may leave, by the way. This is more of a experiment. Look around, try to figure out how it works. Test some inputs. Figure out why they do and do not work. And we will cover more and then we'll move on to pointers. Oh boy. Love pointers. Pointers are fun. Do you guys need the main again, by the way? The code in the main? Okay. I'm going to actually zoom it out so you can see all the code all at once. Here's all the code, slightly smaller, but all of it on one screen. So, like I said, your homework is to put in different strings in here, okay? I have test right in there now. I would try something else, like dude, or maybe palindrome, or maybe something of the sorts. I would highly recommend looking at this code, thinking about what it does. It takes advantage of that array notation that you have just seen. I know, they're just copying down home. I'm sorry.